This is a step-by-step tutorial of how to balance very simple redox reactions. Very simple. We're not going to be doing anything complex in this chapter. That comes in a later chapter. This is just the baby steps into balancing redox reactions. So the very first thing you need to do is figure out the oxidation numbers of all of the species in the chemical reaction. So this one, go ahead, pause the video and give it a try. Well, 0 and 0 and +1 and -1. I know these look like charges. They're not charges. Trust me on that. Oh, by the way, you should also know that this is a synthesis reaction. And a synthesis reaction, by definition, starts with elements and always makes one product. There you go. The next step you need to do is figure out who was oxidized and who was reduced. Now, I still to this day, folks, absolutely do. I always write down oil rig. Because remember, that means oxidation is loss, reduction is gain. And that really helps me out. Okay, oxidation is lost. Who lost electrons? Or we could go this way with reduction. Oxidation means gain. So whose charge went down? Whose charge was reduced by gaining electrons? Let's start with reduction. That always seems to be easier for me to find. Whose charge was reduced? Well, that would be chlorine. Chlorine's charge went down, so that I now know that chlorine was reduced. And then who was oxidized? Well, that has to be the sodium, because whomever is reduced, the other one has to be oxidized, and its charge went from a 0 to a +1. The only way you can become positive is to lose an electron. I've lost an electron. Are you positive? See how that works there? The next step is to write the half reactions. So to write the half reactions, we've already identified who was oxidized and who was reduced, so let's do this. Now that we're ready to write the half reactions, oh, don't forget, you have to start off with, you probably still have it on your paper, but I don't, so I'm going to write oil rig again. And I do like to start with reduction first. So we're going to be starting with reduction by writing chlorine gains an electron. And when it gains an electron, we write that as a reactant. Oh, look, reduction and reactant have the same first letter. Well, that's helpful. So we wrote it as a reactant. Now, if you'll notice, this one is not balanced. Your half reactions, balanced, do have to be balanced. I have 2 chlorines here. So how many chlorines do I need on the product side? 2. But each chlorine lost 1 electron, and I happen to have 2 chlorines, so I need 2 electrons. I like to keep the arrows in line. It makes me less crazy. See these arrows right here? Yeah, this arrow and this arrow. I like to keep those in line because truthfully, it's easier for me to read it. You do what you want. I think it's easier. But anyway, moving on. Oxidized. One of the things that students really want to do is they want to write oxidation by putting in a negative electron. Well, unfortunately, you can't do that. Even though it's losing an electron and you want to say, hey, sodium minus an electron, see, a lot of kids want to do it this way. Sodium minus an electron equals the sodium ion. And I understand why you want to do that, but we don't use negative signs. So let's move this electron over to the product side. So sodium, add an electron to both sides, gives us an electron plus the sodium ion, which makes sense if you read it this way. The sodium ion gains an electron to become the sodium atom. So on the oxidation half, we write the electron as a product. Is the oxidation half reaction balanced? Yeah, it is. Okay, good. Ready for the next step? The next step then is to balance the electrons, because our ultimate goal then is going to be to cancel things out like you did when you had two separate equations, you know. Do you remember when you did a series of equations where you would have y equals mx plus b, that should be an x, on one part of it, and you added, say, 2x plus 3, and you get to add these together. Do you remember doing something like that? Well, that's very similar to what we're going to be doing here. You simply want to make sure that you can add and subtract two sets of equations. Well, to balance the equations, the electrons, I am going to need a 2 here, because look, there's 2 electrons here, I need 2 there. I have to be able to cancel these out, which means I need a 2 here and a 2 here, because if I multiply one thing by 2, I have to multiply everything by 2. Oh, good. Now my electrons are balanced. Now we're ready to add these two equations together. A couple of things you need to know. If species, that means, you know, things like chlorine or the electrons, if a species appear on opposite sides of the arrow, you get to subtract. If they're on the same sides of the arrow, you get to add. All right, here we have 2 electrons on one side, 2 electrons on the opposite side. Good, they cancel. Here we have chlorine, and there aren't any other chlorines that look just like it. So I'm going to go ahead and bring the chlorine down. Whoop, right there. Now, sodium is the only other thing left over here, so I'm going to put the 2 sodium ions, sodium metal there. Bring your arrow down. Here I have 2 sodium ions, plus here we have 2 chlorine ions. We are almost done. See, look, sodium and chlorine, we know from up here, is going to make a compound. So let's rearrange this. We're going to put the metal first, because that's the better thing to do. Plus chlorine yields 2 sodium chloride, chloride. I need the eraser. There we are. 2 sodium chloride molecules. Now, ladies and gentlemen, you are officially done with a redox reaction. This is your final answer. To recap, the first thing you had to do to solve these is 1, find the oxidation numbers. Once you have found all of your oxidation numbers, you have to determine who was reduced and who was oxidized. Then you were ready to write these half reactions. Then we had to make sure the electrons were balanced, and then we added up the 2 equations. To balance this one using the half reactions, I know, you can balance it quickly, not going through all this painful stuff. Like I said before, this is a sort of pre-step to the more complicated stuff. First, let's go through and put down our oxidation numbers. In this case, the oxidation number will be the same as the charge because it's a monoatomic ion. Let's write down oil rig. I like to start with reduction, but it doesn't matter. Whose charge went down? Who was reduced? Well, that would be the hydrogen. So let's start with that. We have a hydrogen ion. We get to write it as, oh look, a reactant to become hydrogen. Well, unfortunately, we have to balance this one. There's 2 hydrogens here, so I need 2 here, which means I need another 2 here, because each ion gained an electron. Now we can do the oxidation half, and I know that's going to be zinc. I like to keep my arrows in order. Became zinc 2 plus, which means that one also was 2 electrons. Now all you have left is to add these up. The electrons canceled because they add to 0, so we end up with 2 hydrogen ions plus zinc yields zinc plus hydrogen. And you are done with this one. Go ahead and pause the video and see if you can do this one on your own. Well, aluminum is a monoatomic ion, so its oxidation number is the same as its charge. And oxygen's always negative too, unless, of course, it's a peroxide, 0 and 0. Oil rig. Whose charge was reduced? Who went down? That would be aluminum. It went from a +3 to a 0. So let's start with the reduction. Here it says I have 2 aluminum ions, because that's an ionic compound. So we have 2 aluminum ions. And on this side, I happen to have 1 aluminum solid. Well, if that's 2 aluminums, then I'm going to need 2 aluminums here. Each one of these aluminums had to gain 3 electrons, but I have 2, so that's 6 electrons. Let's do the oxidation half. This says 3 oxygen ions because I have an ionic compound. So 3 oxygen ions. Oops, I put that 2 in the wrong place. It's a good thing I have an eraser. There we go. We'll try that again. Pen. All right. Ions. And here I have 2 oxygen in the compound. Well, snap, that doesn't work. Let's use the least common multiple between 2 and 3. Well, if I have 3 here, that's 6. That means on this side I'm going to need 6 oxygens. So let's erase that, and we'll do 6. Now I have 6 oxygens on both sides, which in order for 6 oxygens, all of them to gain 2 electrons, well rather to lose 2 electrons, we need 12 here. Are we ready to add these up? No, because I need how many electrons in the reduction half? I'm going to need 12 here. How would I do that? Well, I'm going to multiply this half by 2. So this 2 goes away and becomes 4. This 6 goes away and becomes 12. And this 2 goes away and becomes 4. Now the electrons can be canceled out or add up to 0. So these 12 and these 12. So let's bring our 4 aluminum ions down and our 6 oxygen ions down, which gave us 4 aluminums plus 3 oxygens. Our last step then is to combine these so that they look like this. Well, we already know the formula. See, the formula is already given to us. So we end up with Al2O3 yields 4 aluminums plus 3 oxygens. And let's see, we need 4 aluminums total. We already have 2, so put a 2 in front of this. 2 times 3 as a reality check is 6. We had it. We're good to go. It is balanced. Here we go, putting it all together. Alrighty, the very first thing we need to do is identify the oxidation numbers on everything in here. So the oxidation numbers are as follows. Okay, now we have to figure out who was oxidized and who was reduced. I like to write oil rig. I still do it to this day. And I like to start with reduction. So whose charge was reduced? Whose charge went down? Well, whose charge went down? That's easy. That was iodine. But iodine in its natural state is I2. Reduction is gain, so you write it as a, oh look, there's an R, as a reactant. And that became the iodine ion. However, I have 3 iodine ions. Well, now we have a serious problem because the 2 and the 3, well, that doesn't work. So I'm going to go ahead and go with the least common multiple. So I'm going to put a 3 there, which gives me 6 total iodine atoms. And then I'm going to change this 3 to be the 6 ions that they turn into. So if 6 iodine atoms turned into 6 iodine ions, that means it had to gain a total of 6 electrons. Now I'm going to look at the oxidation half. And in this case, that would be aluminum. And aluminum then lost how many electrons to become the aluminum ion? Well, that would be 3 electrons. Unfortunately, we can't add these two half reactions like this because the electrons won't cancel out. But if I multiply everything here times 2, that gives me 2 aluminums, 6 electrons, and 2 aluminum ions, then I'm ready to add it up. Okay, 3 aluminum, or 3 iodines, 3I2, plus 2 aluminums, and that yields, let's see, we have 2 of these guys, 2 aluminums, and 6 iodines. Now, how am I going to combine these guys? Well, what's the least common multiple between 2 and 6? Because we still have 2 aluminum ions. Alrighty, so that becomes Al(I3). We need to put a 2 in front. So that's 2 aluminum ions, which I had right here, and 6 ions. The final and correct way to write it is to start with the metal first. So we have 2 aluminums plus 3 iodines yields 2 aluminum iodides. And you are done. Go ahead and pause the video and see if you can do this problem on your own. Well, first I'm going to put in the oxidation numbers. And then I'm going to write oil rig. Okay, so who was reduced? Whose charge went down? That's right, cesium's reduced. So we have cesium, and it gained an electron. The cesium ion gained an electron to become the cesium atom. So who was oxidized? Well, the fluorine ion lost an electron, but we have 2 fluorines for the element. So if I have 2 fluorine atoms, I had to have 2 fluorine ions, which meant I have to have 2 electrons. So now we're going to add this guy up. Well, I can't add it up because the electrons don't equal. So I'm going to multiply everything up here by 2. So 2 and 2 and 2. Now I'm ready to add it up. Bringing these down, so we have 2 cesium ions and 2 fluorine ions, and the electrons canceled. So then I'm left with 2 cesium atoms and 1 fluorine element. Well, if you take a look at how this is put together, it's kind of a hint. So I can put this guy together, but keep the 2 in front. 2 CSF yields 2 cesium plus 1 fluorine, and you are done. These next several slides, of course, are for extra credit. Do what you can with those. Let me see them tomorrow, and I'd be happy to give you the points that you earned. In the next video, we're going to talk about identifying and classifying chemical reactions.